For the last few years, the constraint on building artificial intelligence was a matter of physical hardware. Companies sat on wait lists for silicon and navigated strict export controls. But as manufacturing capacity catches up, the bottleneck is moving away from the factory floor and onto the balance sheet. A standard, healthy transaction follows a simple path. A hardware supplier, like NVIDIA, sends a physical GPU to a software client, like OpenAI. The client pays for that hardware with cash, which registers as revenue for the supplier. The client then uses that hardware to run models, generating software revenue from end users to fund their next purchase. This organic demand creates a legible financial ecosystem, where cash flows directly in exchange for goods. This scale stretches standard procurement models. When the infrastructure required to house the hardware costs tens of billions of dollars, the project creates a capital requirement that cash from software sales cannot easily bridge. Building for the next phase of AI requires a 10-gigawatt data center campus. Industry estimates place the all-in cost of a facility like this between $30 and $50 billion for every single gigawatt. 10 gigawatts represents the continuous electrical draw of several commercial nuclear reactors running around the clock to keep a single campus operational. The budget covers land acquisition, custom power routing, and industrial cooling alongside the compute hardware itself. These costs align with national utility projects rather than typical software startup expenses. Traditional lenders often hesitate to underwrite hundreds of billions of dollars for a single facility when the tenant is a high-growth tech company with revenue that is currently a fraction of the debt. That hesitation leaves a massive void in the capital market. To bridge that gap, a specific mechanism comes into play. This represents a $250 billion backstop. A backstop does not mean the hardware supplier is handing over $250 billion in upfront cash. A backstop is a guarantee. It functions as an insurance policy, where the supplier promises that if normal credit markets freeze, or if bondholders fail to show up, the supplier will cover the gap to ensure the lease closes. This guarantee shifts the supplier's position in the market. By absorbing the landlord's risk to ensure the facility gets built, the manufacturer acts as the primary credit enhancer for its own customer. This infrastructure backstop is part of a larger, circular structure that includes a reported $350 billion in direct financing for the chips. The first leg of this loop begins with the supplier making an equity investment into the client. In the second leg, the supplier backstops the building lease, guaranteeing that the physical space to house the AI exists. Third, the supplier extends a line of credit so the client can acquire the hardware to fill that building. Finally, the client uses this funded capital to purchase the hardware, which immediately registers as top-line revenue for the supplier. Trace these arrows backward. If the client's software revenue grows slower than projected, the financial hit moves through every leg of this circle. Every leg of liability points back to the supplier. The client has effectively become an extension of the supplier's own balance sheet, where the reported demand for hardware is directly enabled by the supplier's own capital. This structure is known as vendor financing. In 2001, telecom giants like Lucent and Nortel used it to lend startups the money to buy their own fiber optic equipment. We saw a different application in 2008, when governments guaranteed mortgage debt to prevent credit markets from freezing. Acting as an unregulated shadow bank to intermediate credit at this scale is legal, but it concentrates risk. When the guarantor, the creditor, and the equity holder are all the same company, a slowdown in industry growth focuses entirely on a single point of failure. 3 specific variables determine the stability of this system. Credit rating agencies will provide an external view of the supplier's exposure, while SEC filings will show how these guarantees are quantified as risk factors. The most significant metric is the ratio between the client's organic end-user revenue and their committed capital expenditures. If organic revenue keeps pace, the financing facilitates necessary scaling. If it falls behind, the circular loop faces significant pressure. The AI race now relies on balance sheet capacity and the ability to underwrite risk at a trillion-dollar scale. Whoever can finance the infrastructure will ultimately dictate the direction of the technology.